Hello, Algebra 2 students. I appreciate you finding time to get your notes taken care of. As the title screen suggests there, we are going to spend our time today looking at linear inequalities. So let's get to it. Our objective is the student will learn to graph linear equalities in two-dimensional space. These are the notes for Wednesday, November the 13th. Please write your objective and the date. As always, press pause anytime you need more time and then hit play when you're ready to move on. Now, obviously, the difference between what we're doing today and what we did the day before will be that we were graphing only in one dimension, like on a number line the other day, and today we're going to be looking at multiple axes. We're going to be in our standard Cartesian coordinate plane, the X and the Y grid. Okay, so when we graph a line, we divide two-dimensional space into three subsets. Okay, and those three subsets are, first of all, you have the set of points that exists on the line. Okay, wherever our line is traveling through two-dimensional space, there's obviously an infinite number of ordered pairs, x comma y, that construct this line. That is one subset. Another subset is the set of points on one side of the line, and of course, you also have the set of points on the other side of the line. Now, these three subsets are going to have to kind of be treated with care as we go through getting ready to graph in two-dimensional space, and we'll talk about how to figure out what all is going on here in just a moment. Okay. Now, when we're graphing inequalities on a two-dimensional graph, it's going to involve a couple of steps, just like we did with one dimension the other day. It involved plotting a point and then shading a particular direction. Today, we're going to be constructing a line through two-dimensional space, and then we will shade away from that line one of the two directions according to what the inequality is doing. All right, so our two steps are first drawing the line. Now, we use a dashed line for the non-equal inequalities, such as greater than and less than. On the other hand, we use a solid line for the equal inequalities, which are less than or equal to and greater than or equal to. Okay, so this is very similar to the open dot, closed dot idea that we had for graphing in one dimension. However, in two dimensions, it's not a matter of dots, it's a matter of lines. So a dashed line if the line is a boundary but not included, and a solid line if the line is a boundary and it is included. Now the shading becomes the real catch for some of us. Okay, and we will shade the direction that the inequality says to shade. Now, different teachers offer different strategies and stuff like this for shading on inequalities. My particular preference is to pick a point in space and plug it into the inequality. And what we mean by a point in space is simply a point that is not already on the line. And when we plug it into the inequality, you will see that we will get messages back from the equation that tells us whether or not we should shade towards that point or away from that point. Okay, so let's get into it and have a look at some examples. First example we're going to look at says to graph y is greater than 2x plus 3. Okay. Now to graph this line, okay, just disregard the inequality for a moment and treat it like an equal sign. Y equals 2x plus 3. It is just a line. It is in slope-intercept form. We can use the slope and the y-intercept. As a matter of fact, you can use any of the many methods that are out there for how to graph a line. Okay, so we can use whatever method we want to graph the line, but when it comes time to draw the line, what should we draw it? Should we draw it a solid filled-in line, or should it be a dashed or a dotted line? Okay. In this case, it's going to be a dashed or a dotted line because of the inequality was not an equal inequality. It was simply greater than, not greater than or equal to. Okay, so this is basically what we should be looking at, and I use the slope-intercept form. Cross the y-axis at 3, and the slope was a rise of 2 and a run of 1. Okay, so there's our line. Okay. Now the key is that we are going to need to be able to decide which direction to shade from that line. Now I've said that my strategy is to pick any point in open space, okay, meaning not a point that is on this line. Okay, so we're going to pick any point not on the line, and we're going to plug it back into the inequality. Okay, now as you will find out, some points are more convenient. They have more easily worked with values to plug into the equation and make it easy on yourself. So I have a habit. The origin is a very easy point to work with because of the zeros. Okay, so if the origin is available in open space, I will always pick on the origin as a test point. Okay, now what we're going to do is we're going to take whatever point you picked. I like the origin, but you don't have to like the origin. You can pick any point that you want as long as it is not on this line. And we're going to take its ordered pair, its abscissa, and its ordinate, x and y, and we're going to plug them back into the original equation in place of x and y. So that's exactly what I've done here. The equation y is greater than 2x plus 3. I've taken x and y out and replaced them both with zeros. And the reason I like the origin is because those zeros cancel a bunch of stuff out in the equation, makes it easy to simplify, and when this is simplified, we have a statement that says 0 is greater than 3. Okay? Now, the real question is that a true statement? Is 0 greater than 3? Okay, well, I think everybody knows the answer to this one, but for any statement like this, all we would have to ask ourselves is which one is further to the right on a standard number line. And obviously 3 is further up on the number line. So this is not a true statement. 0 is not greater than 3. Okay, so what is happening there is the origin just sent us a message. It is saying, hey, I am not in the area that you're supposed to shade. Stop looking at me. Okay, go look on the other side of the line. That's where you should be shading. Okay, and unless you are very confident in your math skills, then I would go ahead and pick an additional point from your graph and plug it in. Okay, and again, you can pick any point on the opposite side of the line that you want. Okay, I just went out into open space a little bit, and I happened to pick on -3, +3. But you can pick any point that you want on the other side of the line. But I'm going to substitute -3, +3 back into the equation just like I did with the origin and see if that gives us a true statement or not. So let's have a look. Okay, there's the original equation. I picked on -3, +3, so I plugged those values in. Now all we have to do is simplify the math there. We've got 2 times -3 there in the center. That's -6. And on the right, you got -6 plus 3, that is -3. Okay, so we end up with a statement that says 3 is greater than -3. Okay, now we're expecting this to be a true statement, so let's see if it is. 3 is greater than -3. Yes, that is correct. When you put them on the number line, 3 is further to the right than -3. Okay, so once again, a message is being sent to us by -3, 3. Okay, it is saying, since we got a true statement, yes, I am in the area that's supposed to be shaded. You should shade towards me. Okay, so that gives us 2 real good reasons to shade up and to the left of this line. We checked the origin and it said, no, do not shade over here. We checked -3, +3, and it said, yes, definitely shade over here. Okay, so you shade up and to the left of the line, and that's your answer. Okay. Let's look at another one. Graph 2x plus 3y is less than or equal to 6. Now, once again, you can use any method for graphing linear equations that you like. If you've had somebody show you how to graph by axis intercepts in the past, then this would be a perfect opportunity to do that since this equation is in standard form. However, if you're not familiar or comfortable with that, then you can always get your equation into slope-intercept form and graph from there. Okay, so slope-intercept form would involve subtracting the two x's over to the right and then dividing the entire equation by 3. Okay, so after you do that, you should have a slope-intercept form of y is equal to negative 2/3 x plus 2. And actually, I've got an error in my notes right there. I did not get my inequality in there correctly. Okay, the original problem had a less than or equal to sign in it, and nothing happened in the problem to change that, so it should still be less than or equal to right there. Okay, so let's go to our graph, okay, and let's ask ourselves on this one, should we draw a solid line or a dashed or dotted line? In this case, this one's going to be solid. It's going to pass through 2 on the y-axis, and it's going to fall 2 units and run 3. Okay, so there's what this line ought to look like in the graph. All right, now here we go again. We need to pick any point that is not on this line and plug it into the inequality. Okay. Well, once again, and this is going to be a recurring theme with me, I am always going to pick the origin if the origin is available to be picked. Okay, so the line does not pass through the origin, so I'm going to select 0, 0 to plug it in and see what happens. Okay, so let's have a look at it. There's the original equation, 2x plus 3y is less than or equal to 6. I plugged in the origin, x equals 0 and y equals 0. Obviously, that cancels out the entire left side of the inequality, and we have 0 is less than or equal to 6. Okay, so is this a truthful statement? Is 0 actually smaller than or equal to 6? Obviously it is. Okay, 6 is further up the number line to the right than 0 is. So the message coming from the origin is yes, you should be shading towards me. Okay, and I usually make it a habit to go ahead and select an additional point just to make sure I have not done anything foolish in my math when I plugged in the origin. So I'm going to go to the other side of the line, and this time I'm going to select 2, 2. You can pick any point you want above and to the right of the line, but typically if you can keep your values positive, that usually works out a little better for us, and also keep them small, that works out a little better for us as well. Okay, so I'm going to plug it back in again real quick. 2x plus 3y is less than or equal to 6. Going to use point 2, 2, plug it in, and let's see what we get. Now 2 times 2 is 4, 3 times 2 is 6, and on the left 4 plus 6 is 10. Now the origin said yes, shade towards me, and now we're on the other side of the line, so we should be expecting a false statement this time. And we have 10 is greater than, or I'm sorry, 10 is less than or equal to 6. That is obviously incorrect. Okay, so that 0.22 is saying no, do not shade towards me. I am not in the right area. Okay, so what we ought to be able to do now is go back to our graph, and we're going to shade left and down from underneath the line towards the origin, but away from 2, 2. Okay, it's really not that big of a deal to graph this, just a couple little bitty new things to remember. Okay, and I have a couple of examples that I want you to copy down and try on your own there. I realize that you do not have graph paper, but just doodle yourself a little graph there. Okay, and do the best you can. Try to keep it as neat as possible. I know for some of you, keeping it neat is not an easy chore since our handwriting is not so good. But at any rate, here we have an equation. 2y is less than 10x. minus 6. Let's solve that. Let's graph it, and let's pick a test point and decide which direction to shade it. I also have another example, and the second example is 3x minus 4y is greater than or equal to 12. So again, do the best you can. I know you don't have your graph paper there or anything like that. Just do the best you can with it. Solve it, draw it, pick a test point, and decide which direction to shade it. I appreciate you finding time to take your notes. I will see you in class on Wednesday.